One of the origins of this project was trying to make the slimmest vacuum possible. It really represents that Dyson engineering ethos of doing more with less. We wanted to get everything in the same diameter as the handle of a supersonic. That means that it's really comfortable to hold for the majority of hand sizes across the world. And the biggest constraint was keeping everything within that 38 millimeters. We came close to failure several times simply because we had to invent every technology in this machine from scratch.
So this hyperdynamic motor spins at 140,000 RPM and has been micro-engineered down to 28 mil in diameter. The motor generates a lot of heat because of the speed it's spinning, and this new moulded frame dissipates the heat whilst being a secondary diffuser, so optimizing the airflow. The dual purpose of the motor mount was to protect the motor from drop and shock and also from vibration, which can result in more acoustic noise. This is our smallest, fastest vacuum motor, and without it, the machine would not have been possible.
So this machine is very maneuverable, so you can move it in 360 degrees anywhere you want around the floor. And also, due to having two sets of counter-rotating brush bars, you can go over debris with the front set of brush bars, you can go over the back, because the debris is always going to be swept into the center of the cleaner head and up into the bin. The material that we use on our brush bars is very gentle on hard floors. And the fact that we have our exposed tips on our brush bars mean that we have full edge-to-edge cleaning along the entire width of the cleaner head. And also because it's a very low head, you can still get under furniture into the tighter spots. So with our tests, we pushed it to quite an extreme. We wanted to make the design as robust as possible. So we started off using 30 centimeter long Asian hair, which is the toughest, it's the hardest to snap. But naturally the conical shape means the hair starts to migrate to the end. It doesn't really build up and start to be able to knot and tangle. Then also near the end of the brush bar, we have a few angled ribs that encourage it to build up into a ball. That ball will fall off and then you can just go over it and pick it up.
As you're using the machine, the airflow is forcing the debris up to the top of the filter, and the airflow is actually compressing that debris, so it's maximising the bin capacity. Within the machine, we have two layers of filtration. So these two layers combined result in a filtration efficiency of 99.99%, down to 0.3 microns. The first layer is this stainless steel chemically etched mesh. So this is going to be capturing about 70% of the debris that you're picking up. And this is all particles that are bigger than 350 microns. Then we move on to the filter assembly. So this has a protective mesh, and then the filter media itself has been pleated to a really fine pitch. This allows us to maximise the surface area of the media and optimise the performance. Another challenge we faced was designing this valve. It needs to open sufficiently to allow large debris to enter into the bin. On a bin empty, we need it to lie completely flat in the opposite direction. And then when the machine isn't in use, we want it to return back to vertical and be completely sealed to ensure no dust dropout. The combination of compressed debris and a small aperture results in significantly less dust flume on a bin empty.
So this is our first connected vacuum, and that means via Bluetooth you can look at your cleaning statistics, maintenance guides, and even change some settings on the machine. It took a little over a year to get from the concept start to this first working prototype. And that was really to test the core elements that make this work. And then it took even longer to go from this first prototype to our first production models, which give us this really amazing, convenient, easy to use grab and go cleaner. And really that's the tip of the iceberg for this format and future technologies, but probably can't say too much more at this stage.